We know the derivative of e to the x is itself. But what is the derivative of an exponential with a different base? That is the goal of this video. The base a could be any positive real number. It has to be positive, otherwise the exponential doesn't make sense. I would use a trick that is very common in mathematics. I want to solve the general problem for all values of a. I already know the answer for one value, for e. I'm going to try to write the general case for all a in terms of the one case I can solve. So write a to the x in terms of e to the x. And here's how to do it. Any positive number a can be written as e to the ln a. This is by definition of ln. Then a to the x can be written as e to the ln a to the x. And now I can use the properties of powers, and perhaps it is more common to write this as e to the x ln a. And that's all I need. I have written a to the x in terms of e to the x. That's going to allow me to take the derivative. So now, the derivative of a to the x is, instead of as a to the x, I will think of it as e to the x ln a. I know the derivative of e to the x is itself, so the derivative of e to a function, by chain rule, will be itself times the derivative of the exponent. And now that I have taken the derivative, I can rewrite this as originally a to the x. And here I have x times a number, so the derivative is just the multiplying number, ln a. And that's my final answer. The derivative of an arbitrary exponential is itself times ln of the base. Notice that when a equals e, I get ln e, which is 1. So this term disappears and I recover the identity I already knew. This strategy, reducing a bigger problem to a smaller problem we have already solved, is very common in mathematics. Here's an exercise for you to practice it. You already know the derivative of ln x is 1 over x. But what is the derivative of logarithm on a different base? As a hint, use the logarithm change of base identity.